you a definition the other day. What did I give you as a definition? The gradient at a certain point is actually the derivative at a certain point is actually the gradient of the tangent at that point. Right? Did I use that terminology? Right. Okay. So we also know there's a formula for the derivative, right? The formula for the derivative denoted f prime of x is equal to the limit as h tends to 0, and this limit is introduced because we want to bring the points as close as possible. So the limit as h tends to 0 of f of x plus h minus f of x, right, all over h. That's what we know as the derivative. Okay. So whenever we speak of first principles, or a question wants you to find the derivative using first principles, this is what you're going to do. You write down this formula, you substitute, and the rest is history. Good? Okay. Now obviously, I want to reinforce this. Substituting here is just simply algebra. It's what? Algebra. So my lesson from calculus should actually conclude at this point, because the rest is algebra, right? Which you should already be competent in. But because I'm a nice guy, I'm going to show you examples. Okay, so example 1, and you should work with me here. I'm going to take a function f of x, and I'm going to use that one, f of x is equal to 2x squared. Okay, now as you already are familiar, is 2x squared. What type of function is that? It's a parabola, right? And as you know, the parabolas form part of the family of polynomials. And when you have a polynomial, to find its derivative, you can use the shortcut for polynomial derivatives, which is called the what rule? The power rule. So, Mahir, can you apply the power rule to this, please? The power rule will have this as 2 times 2, and then 1 minus the exponent, which gives me 4x. Very simple. Okay, so if you get a question like this, and you need to find the derivative using first principles, I'm just going to write there, use first principles. Then we need to write out that long formula. And as you know, for grade 12, I don't give you formula sheets, right? So you need to know the formula. And I've shown you the full derivation of that formula. Okay, now this shortcut gives us what our answer needs to be. Our answer needs to be 4x. So if you get an answer that is not 4x, after doing first principles, you know that somewhere there was an error. Okay, so let's go on to the next slide. So f of x is equal to 2x squared. What is f of x plus h? Come? It's 2 into x plus h all squared. How do we get that? Wherever we see x, we're going to put in x plus h. Wherever we see x in this formula, we now put in x plus h. Kothar, are you good with that? Okay. So, now, first principle says f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Now what's very important, I'm just going to move my equal to sign over this way so that I have more space to write. We already found f of x plus h. Do you see that? That's this whole thing over here. Yes or no? So I'm just going to put that thing in this thing's place. Great. And then I'm going to take this thing and I'm going to put it in place of that. The minus here is part of the formula altogether, right? So now I've got the limit as h tends to 0. And f of x plus h is this thing over here, 2 multiplied by x plus h all squared minus, and f of x is this thing over here, which I'm going to put in blue, 2x squared. Okay? Divided by h. Okay. Now I go, the rest, all I do is I just multiply these things out until I reach a point where I evaluate the limit. Now you know evaluating the limit involves substituting in the value that it tends towards, right? But I can't do that right now because it's going to be undefined, because I got h at the bottom. Are you with me? But I haven't fully evaluated this thing over here. So I'm still going to write limit as h tends to 0, and I'm going to multiply this thing out. That's going to be 2 into x squared plus 2xh plus h squared minus 2x squared. Do you all see that? divided by h. I just squared this thing. X squared, 2 times x times h is 2xh, and then h squared, right? And this minus 2x squared is multiplying that in over there. I'm going to further write limit as h tends to naught of 2x squared plus 2xh plus, sorry, not 2xh, what should this be? 4xh plus 2h squared minus 2x squared all over h. Now very importantly, you can see here that I've got 2x squared minus 2x squared. That will always happen, right, for these grade 12 calculations, right? So let's continue further. I'm now left with the limit as h tends to naught of the following: 4xh, do you see that? Plus 2h squared all over h. Now I still write limit as h tends to naught, are you with me? Of, factorize this now. I can pull out h as a common factor. You can pull out 2 also. I'm not going to worry with 2. Do you know why? Because I'm not worried with 2. 4x plus 2h. Okay? Okay. So this here I'm going to divide by h. The reason being is I'm only interested in h cancelling out. Are you with me? So that's why I'm not worrying with the 2. And this here, now I put the 0 in. Now I evaluate the limit. Once I get here, I can evaluate the limit. And let's go with sky blue. Put 0 in the h. Right? And then I get an answer of 4x. And now I don't write the word limit again because I've evaluated the limit. Okay. So up until the time that you substitute, you leave limit out. I mean, you put limit in. Okay, are we good, people?
Right now.
Okay, so that concludes example number 1, people. Very, very simple. Just find f of x plus h, find f of x, write down the formula for the derivative, substitute, simplify, evaluate the limit, and you get your answer. Okay, let's move on to another one.